Hello, welcome students for the online lecture of fluid power systems. So we are discussing the first module, that is introduction to fluid power systems. So today we will discuss filters and strainers. The performance, efficiency and service life of a hydraulic system depends on precision of components used. It is not just sufficient if the components used are of high precision and accuracy. The same precision and accuracy should be maintained throughout the service period of the hydraulic components. A filter is a device whose primary function is retention of insoluble contaminants from the fluid by some porous medium and strainer. In simple words, a filter or a strainer is a device whose function is to trap insoluble contaminants contained in a flowing fluid. Porous medium simply refers to screen or filtering material that allows fluid to flow through it but stops other materials. Types of filters. Filters are broadly classified into three types based on the following factors. They are method of filtering, size of porous in the filtering material, location of the filter. Methods of filtering. There are three types of filtering methods adopted in hydraulic system. They are mechanical filters, absorption filters, adsorbent filters. In mechanical method, metal or cloth screens or a series of metal discs separated by thin spacers are used. This method is capable of removing only relative coarse particles from the fluid. Absorption filters use porous and permeable materials such as paper, pulp, cloth, cellulose, asbestos as filtering medium. In this type of the particles are actually absorbed as the fluid penetrates the material. Adsorbent filters. Adsorption is a surface phenomena and refers to the tendency or affinity of the particles clinging to the surface of the filter medium. Filter medium include activated clay and chemically treated paper. The capacity of such filters depend on the effective area of surface of filter medium available. So in figure you can see a full flow filter. Necessity arises in some hydraulic system that the complete oil must enter the filter element as its inlet side and must be expelled out through the outlet after crossing the filter element fully. In case of full flow filtration, the size of the filter is so designed to accommodate the entire flow at that part of the circuit. This is obviously efficient in terms of filtration, but incurs large pressure drop. This pressure drop increases as the filter gets blocked by contamination. Generally, these filters are provided with a safety valve before it, which cracks when the filter is unacceptably blocked. The figure shows the principal full flow filter. Bypass filter. In some hydraulic system application, only a portion of oil is passed through the filter instead of entire volume, and the main flow is directly passed without filtration through a restricted passage or venturi. As the main flow passes through the venturi, a localized low pressure is created. This pressure differential across the filters influences the filter to draw a portion of the fluid through the filter and hence called proportional flow filter. Location of filter. Various locations are used to arrange the filter either in the return line or in the pressure line, each having its own advantages and disadvantages. In general, the following are the preferred locations: intake filter or inline filter, pressure line filter, return line filter. So inline or inlet line filter, we are going to fit the filter before the pump. So it is in between reservoir and pump. So in pressure line filter, we are going to fit the filter after the pump. After filter, it will go to the system towards the directional control valve and towards the actuator. And in return line, we are going to fit the filter in the return line after doing the work in the actuator. The oil has to return to the reservoir. So in that line, in return line, we are going to fit the filter. In inline, filters are provided just before the pump to protect the pump against contamination in the oil. These filters must be designed to give a low pressure drop, otherwise the pump will not be able to draw the fluid from the tank. To achieve low pressure drop across the filter, a coarse mesh is used. Pressure line filters are placed immediately after the pump to protect valves and actuators and can be finer and smaller mesh. They should be able to withstand the full system pressure. Most filters are pressure line filters. Return line filters are those which filters the oil returning from the pressure relief valve or from the system, that is actuator, to the tank. It is placed just before the tank. Reservoir. So in figure you can see the reservoir, and the main important parts of the reservoir are tank, level side glass, baffle plate, breather and filter, return line pipe, pump inlet, bottom plug to drain oil. A tank is made out of mild steel by welding either rectangular or square type, rectangular being the most common. Level side glass, this is provided on the outer surface of the tank, which indicates the maximum and minimum level of the oil in the tank. Baffle plates are provided across the tank to prevent turbulency in the fluid before reaching or enter the inlet point of the pump. Breather is provided on the surface of the tank to remove the externally entertained air over the top surface of the oil. Filter caps are provided to facilitate filling of reservoir with oil after periodic cleaning. Return line pipes. The return lines should be on the one side of the baffle plate and should be away from the pump inlet. These pipes may terminate above the fluid level in the reservoir to prevent siphonning. Pump inlet line. The pump inlet line should be at least 50 mm above the tank floor and at least 75 mm below the minimum level of the oil in the reservoir. Bottom plug to drain oil. This is the lowermost element of the reservoir really used. The plug is opened when the reservoir is to be thoroughly cleaned, especially to remove solid contaminants settled at the bottom of the reservoir. So here you can see the machine which is used for forging, which is operated by the hydraulic system. So here you can see a ram which is connected to the cylinder, and to the ram we are going to here you can see the two cylinders which are hydraulically operated. So in forging system, in the forging operation, we require very high force. For that purpose we are going to use hydraulic system. So in between the dies we are going to keep the workpiece, and it requires very large impact forces to bring the metal in the to the shape of the die. So we are going to use the hydraulic system for this forging operation. So when high pressure oil enters in the main cylinder, so it is moved on with a very lot of force and to do the work. To lift the heavy job we are going to use two more actuators to lift the ram. So this process you can see in the forging shops. So some more examples of hydraulic systems are service stations, JCBs. So for the movements of the arms of the JCBs to movement of the packets of the JCBs, we are going to use the linear actuators. So this is another application of using the hydraulic systems. So for one cylinder is used to clamping the job, and another cylinder is used for the machining. So this is application of hydraulic system. So this is the explanation of extension and retraction. With the two positions of the valve, we have shown the extension and the retraction. In one position of the valve, the cylinder is extending, and in another position of the valve, the cylinder is retracting. So with symbol, we have shown the reservoir, filter, pump, direction control valve, solenoid operated direction control valve, that is 4x2 solenoid actuated valve, and the same actuator we have shown extending and retracting, and two positions of the valve. So this is another example of hydraulic system, that is lever system. One side load is there and other side actuator we are going to use. So this is known as first class lever. To do the work, we are going to use this actuator along with the lever. So here in this actuator, the linear motion is converted into rotary motion by using rack and pin iron. So in another actuator, you can see the cylinder which is used to embossing or punching. So properties of hydraulic fluids. We will discuss the properties of hydraulic fluids. First one, viscosity. It is a measure of the fluid internal resistance offered to flow. So viscosity is nothing but it is the internal resistance offered to flow. So if viscosity is high, resistance offered to flow is high. So in hydraulic system, we want to maintain the viscosity, moderate viscosity. It must be not too high or it must be not too low. If it is too low, there will be wear of the parts. If it is too high, there will be power loss. Viscosity index. This value shows how temperature affects the viscosity of oil. The viscosity of the oil decreases with increase in temperature, and vice versa. The rate of change of viscosity with temperature is indicated on the arbitrary scale called viscosity index. Oxidation stability. The most important property of hydraulic oil is oxidation stability. Oxidation is caused by a chemical reaction between the oxygen of the dissolved air and the oil. The oxidation of the oil creates impurities like sludges, insoluble gum, and soluble acidic products. The soluble acidic products cause corrosion, and insoluble products make the operation sluggish. So demusibility, the ability of a hydraulic fluid to separate rapidly from moisture and successfully resist emulsification is known as demusibility. Lubricity, the ability of the hydraulic fluid to lubricate the moving parts efficiently is called lubricity. Rust prevention. So these are all the properties which hydraulic oil must have in it for smooth operation of the hydraulic system, for more life of the hydraulic system. Rust prevention. The moisture entering into the hydraulic system with air causes the parts made of ferrous materials to rust. This rust, if passed through the precision made pumps and valves, may scratch the nicely polished surfaces. So the contaminants which are present in the oil may cause the scratches on the moving parts of the components, and there may be a internal leakages. So the corrosion particles must not form in the oil. So inhibitors are added to the oil to keep the moisture away from the surface. Pour point, the temperature at which oil will clot. is referred to as a pour point, that is the lowest temperature at which the oil is able to flow easily. The lowest temperature at which the oil is able to flow easily, that is known as pour point. Flash point and fire point. The flash point is the temperature at which a liquid gives off vapor in sufficient quantity to ignite momentarily. So momentarily it will ignite or flashes are formed when the flame is applied. The minimum temperature at which the hydraulic fluid will catch fire. At what temperature the hydraulic fluid will catch fire? The minimum temperature at which the hydraulic fluid will catch the fire and continue burning is called fire point. Neutralization number. The neutralization number is a measure of the acidity or alkalinity of a hydraulic fluid. Density. It is that quantity of matter contained in the unit volume of the substance. Compressibility. All fluids are compressible to some extent. Compressibility of a liquid causes the liquid to act much like a stiff spring. The coefficient of compressibility is the fractional change in a unit volume of liquid per unit change of pressure. So now we will discuss the effect of temperature and pressure on hydraulic fluid. Viscosity is the most important property of the hydraulic fluid. Temperature has an adverse effect on viscosity of hydraulic oil. Hence, it has to be seen that the operating temperature of a hydraulic system is kept at a reasonably constant level. Otherwise, there will be a tremendous losses in the system which will reduce the overall efficiency. A hydraulic fluid that is too viscous generates more friction and heat and usually causes high pressure drop, sluggish operation, low mechanical efficiency and high power consumption. On the other hand, low viscosity fluids permit efficient low drag operation but tend to increase wear, reduce volumetric efficiency and promote leakages. So these are the effect of temperature on the hydraulic fluid. So remaining things we will discuss in the next class. Thank you.